For the audience, here's Angel Vasquez.
The quest of life on Mars. Since the beginning of man, the question that has stumbled the minds of old and new has been the idea of life existing on another planet. Unfortunately, that question still remains a mystery. But through the exploration and efforts of the Curiosity rover through NASA, the question may very well be answered soon. By collecting some samples from the Gale crater using the DAN, standing for Dynamic Albedo of Neutron Experiment, a Russian instrument for active pulsing neutron, a probing of the near surface soil, according to M.L. Ladvik and I.G. Mitrovanov. The effort used is based on the significant dependence of surface level reflected neutron flux and the time profile on the content of hydrogen in the nuclei in the soil. The experiment is built upon the fact that 3.5 million years ago, the genetic makeup of Mars was very similar to Earth. The Gale crater has been observed to once have been a lake bed, with many networks of rivers leading into it. The motto, "Follow the water," has become a popular one amongst the members of NASA, as all life requires water to survive. Using this as a reason to focus on the Gale crater to look for signs of life and pairing this with knowledge of previous experiments, we can hopefully try and get one step closer to finding life on another planet. I chose this topic for my speech because I once studied this for a project of which inspired me greatly to want to become an engineer. As I thought at the time, the very thought of finding life on another planet was so cool that I one day wanted to be an engineer. And so I wanted to talk about the science behind the amazing discoveries by the Curiosity rover and other techniques that are being considered today. The Curiosity rover has brought many valuable details in the 1 year that has been on the surface of Mars. The, the instrument, nicknamed the DAN, consists of a pulse neutron generator and a detector electronic module for thermal and epithermal neutrons, as stated by I.G. Mitrovanov, as it releases a pulsating signal of 14 MeV neutron source, which allows for the neutron flux to be studied. This is because when neutrons collide with other nuclei, they lose energy. And since hydrogen is only protons, the neutrons lose a great amount of energy. Since water is obviously a main component, or a main component of water is obviously hydrogen, this is why the Gale crater is being studied. The main neutron absorbers on the face of Mars are chlorine and iron. Although chlorine has seen to have a larger spatial difference than iron, and as such, it is chlorine that has been examined closer than the latter. The data has shown that that although there might not be a lot of water on the face of Mars, and is in fact much shows closer data related to the Atamacan Desert, the driest desert on Earth, which does not discredit the findings because it was once known to be an ancient seabed. The findings point that there could still be hydrated minerals near the surface levels, which are known to not lose water through natural evaporation, and which are known to hold up to 7 to 15% of water. Despite the disappointing findings, the NASA Odyssey orbiter has found a big difference in the data as it has been able to observe up to 600 kilometers compared to the 1 kilometer the Curiosity rover has traversed. In the past, the previous expeditions, like the Viking experiment, observed samples in the soil that didn't produce much as they were conducted incorrectly. This is due to inexperience at the time, as they simply took a scoop of soil and exposed it to food to observe if the microbial life would release carbon dioxide by consuming the food. But the results provided proved inconclusive, as when introduced to the soil, they did produce carbon dioxide, but it showed no definitive proof of life, compared to when they exposed the soil to water to see if it would also release carbon dioxide, which unfortunately it didn't. It released oxygen, which stumbled the scientists at the time. As such, they would search for organics, as they are carbon containing compounds that all life is dependent upon. But unfortunately, none of it could be found. As such, the data was shrugged off at the time and chalked up to the chemicals within the soil causing such a difference. But some still hold out hope that there was still life on Mars. The investigation was rekindled through the discovery of perchlorate on the surface of Mars, a highly reactive substance which would explain the lack of soil. A team led by Rafael Navarro Gonzalez would conclude that perchlorate would completely destroy any carbon compound in the soil during the heating process, as stated by Professor P. McKay, a member of the team and author of the article How to Search for Life on Earth, and would explain the findings of the experiment. Though it seemed discouraging, microbial life was able to expand much further in the 40 years between the Viking expedition, as they use culture-based methods using a petri dishes, which are no longer considered definitive. Now, DNA detection and sequencing, which can use data from uncultured organisms, and now teams are dedicated to finding new ways of DNA extraction that they can incorporate to the expedition. But one drawback is that DNA on Earth is very similar, and of course we haven't explored any other DNA. But and another way that we can try and find life is by looking at the proteins on the face of Mars to see if there is any. But the problem arises when deciding which proteins to use, as there are millions to choose from. But Professor Porello Garcia, author of the article and member of a leading team, is developing ways to discover these proteins and add them into future technologies for later expeditions. This is through aspartame, which employ antibodies that can detect modules which are smaller and less complex than full proteins. Through these new innovations, we can try and plan out a better way that can employ each method in using a autonomous microchip, DNA detector, and a way to characterize amino acids through different instruments in the later expeditions. Through the mistakes of old and new innovations, we are approaching the truth behind the greatest question of man and hopefully find life on Mars. By searching the Gales crater and new methods in microbial technology, we can reach this goal step by step, and as our instruments become more and more advanced and our exploration of Mars expands, we will soon get the answer, one day.